Thank you all for joining me today. I'm going to be talking about the SB2030 as designed tool. And the three areas we'll be talking about today is a little bit of an overview of the SB2030 program, how to navigate the SB2030 tool, and then how to create a model in the SB2030 tool for projects going through it. SB 2030 is part of a broader set of programs offered by the state of Minnesota for public buildings called B3, Buildings, Benchmarking, and Beyond. And yes, it was started pretty much at the same time as the movie Toy Story came out, so that whole To Infinity and Beyond, it was topical 15 years ago. The program is administered by the Minnesota Department of Commerce and the Minnesota Department of Administration, and it receives funding through Conservation Improvement Program funding, so the SIP surcharge on energy bills. A portion of that goes to B3 benchmarking, SB 2030, and these programs. The entire suite of tools and programs include B3 guidelines, which is for new buildings or renovations to meet sustainability goals for site, water, energy, indoor environment, materials, and waste. SB 2030 is the energy use and carbon emissions goals for buildings that get state bonded. B3 benchmarking is for existing buildings and new buildings to track and compare their energy use and see how well they're doing compared to their previous energy use, as well as peer buildings and how well they're doing compared to the current state energy code. B3 energy efficient operations is designed to help people minimize the energy use during the building operations. This program can be applied to any existing building, but is often required if a building doesn't meet the SB 2030 goal once it's in operations. This is a way to try to tune up a building and get it back on track. And then finally, the B3 post-occupancy evaluation, which is used to determine the occupant perceptions of the building so that we can fine-tune how we design these buildings and create better spaces for those occupants. All of the B3 tools and programs are designed to be based on actual outcomes and measurable outcomes, not just principles or concepts. So we try to do a lot of tracking. What is the outcome? How is this actually playing out in the field? There are really three types of code requirement, energy code compliance methods. The most common is called prescriptive, and it's essentially a checklist of items that you need to accomplish in your building to be considered code compliant. If you do these 16 or 32 things, you're code compliant. Performance-based code compliance is saying that your building is expected to use less energy than that prescriptive building. It is usually done with an energy model. You do a comparison. If your modeled building energy consumption is using less energy, great, you're code compliant. Both of these are about the design of the building, not actually about how the building uses energy in the real world after people move in. The final type is outcomes-based. It's not very common in national model energy codes yet, but SB 2030 and a few other energy requirements are moving towards that. With an outcomes-based code requirement, you're not code compliant until you can demonstrate that your building in the real world, with all of the things that actually are happening, uses less energy than whatever the code requirement is. So for SB 2030, it's currently a 70% reduction from a typical existing, moving to 80% in January 1st. To fully be SB 2030 compliant, you have to show that your building's meter is actually using that much energy or less, not just that you designed it to meet that. So mostly today we'll be talking about how you can demonstrate a design meets that intent, but the final adjudication is based on your actual energy performance. So SB 2030 is one of the largest outcomes-based energy standards in the country. There is a few, IGCC, for instance, is using some outcomes-based code compliance, but it's pretty rare still. It sets an energy use and carbon emissions reduction from a typical building that was around in 2005. And it requires 10 years of actual performance to prove that you have met it. There is an exception if you can prove that you cannot get to that energy or carbon goal with strategies that have less than a 15-year payback currently, and in January that'll be updated to 12 years, and I'll get into why in a little bit. But so right now it's a 15-year maximum payback that you have to implement. That'll be coming down a little bit. So in 2005, the typical existing building used 100 kBTUs per square foot. In 2005, the goal was set at half of that, so 50 kBTUs per square foot, and ratcheting down 10% per year until 2025. Oddly enough, we don't actually make it all the way to 2030 and net zero in the legislation. Somewhere along the line, some legislator changed that, and we get to 90% at 2025. So we're getting close to net zero within spitting distance, but the requirements end in 2025, and then it's 90% going forward. As I mentioned, in January, we'll be moving to an 80% criteria for SB 2030. And as part of that, we've been revisiting a few of the rules, and as we've learned things, as projects have participated, we're making a few changes. First off, we're going to be more heavily emphasizing the evaluation based on both carbon and energy use. The majority of the time, the energy use is the governing factor because the carbon emissions take into account the decarbonization of our electric generation, which has been about 30% since 2005. So a kilowatt hour today produces about 30% less CO2 than a kilowatt hour in 2005. But as we get to that 80% criteria, and as heat pumps have become more cost effective, we expect to see more heat pumps in buildings, and sometimes that can actually get you up above so that the carbon emissions will get tripped up. So going forward, starting in January, we'll be displaying carbon more prominently in the tool. We're going to be modifying the requirements around on-site renewable energy evaluation. Up until this point, it's been a requirement, but it's been somewhat perfunctory. Because of that 15-year payback requirement, solar has usually not been there. We're really right on the cusp of solar being cost-effective on a broad scale, as well as the fact that at 70%, just the thermodynamics and physics of a building, you can get close to 70% with just energy efficiency. At 80%, we expect many projects to have some PV to get to that 80% reduction. So we will be seeing projects being required to have photovoltaic to be SB 2030 compliant. We are going to allow a campus-based approach to renewable energy development. So if you have a building on a campus, you can put that renewable energy either on your building or somewhere else. We also are going to allow people to do off of their building after they've filled up the economically feasible portion of their building roof, their own site. They can then do renewable energy credits or other off-site renewable energy. We're going to eliminate the relaxed standard for renovation projects. Currently, if you have a renovation, you only have to hit half of the reduction that a new building does. We have found that most renovations are able to hit the full standard, and with the 15-year payback kind of cap, we think that'll cover it. So in the future, you'll have to get to 80% with a renovation, and if you can't, you'll have to demonstrate that it's because it's not cost effective. We're going to exclude EV charging and major process loads. We don't want to penalize buildings for providing a more efficient way to have people drive around, even with a relatively heavy coal mix on our electricity. Internal combustion engines are just so inefficient that it's better to have even coal-generated electricity powering an electric car than to have a gasoline-powered engine. So we don't want to penalize those kBTUs. So going forward, you have to separately meter the EV charging stations so that you aren't counting that against your building's energy consumption. And then finally, we're going to have biomass will only be counted as renewable energy if you can demonstrate that it is being produced in a carbon neutral manner. So basically, we're looking at that biomass has to be a closed loop. You have to be generating new biomass for every cord of wood you're burning. You have to show that you have a renewable and a consistent cycle that you're growing more wood. In the future, we want to add a time of day CO2 emissions factor. What we're finding is when you use energy is becoming as important, if not even more important, than how much energy you use. As we have more and more wind and solar on the grid, we aren't quite to the point yet, but 5 or 10 years from now, we expect to be at a point where the wind produces as much energy as the grid needs some hours of the day, and so there's no marginal emissions or cost to use that energy. We're seeing that already in California, where if you're using energy during the middle of the day, it's essentially no cost and no environmental negative impact to it. So it becomes these kind of, what is the key hours for energy consumption? We don't have a consistent statewide data source for carbon emissions throughout the entire year by the hour, so we haven't been able to include that in the tool yet. One last thing before we start diving into the tool. Every project that goes through SB2030 gets published to the case studies database. And in the case studies database, there's some basic information about what strategies were used, as well as how well that building is performing compared to its design and compared to the 2030 standard. So you can see if there's other buildings that have met the goal that you have for your building, if that's a challenge for most buildings, what strategies they have used. So next I'm going to go and talk a little bit about the SB2030 tool itself. The SB2030 tool uses DOE2 to provide an hourly simulation of the energy consumption of the building. It takes the physical building definition that you all provide, operations that is either provided by the design team or defaulted to typical operations for that building type, and the local weather, and runs a simulation in the cloud to say how much energy and emissions that building would generate. The SB2030 as design tool, we expect to work for about 80 or 90% of the buildings that go through the SB2030 program. About 10 or 20% of the time, we think you will need to use a more robust energy modeling tool. So SB2030 is designed to simplify making your energy model for SB2030 compliance and will be applicable for most buildings. But if you have a particularly complex mechanical system or you have very irregular hours, you might need to use Energy Plus or eQuest or IESVE or one of the other simulation tools. The hourly simulation looks at the weather in a typical year, sun position, number of peoples, how much of the lights are turned on every given hour of the year, how much air leakage is in the building, ventilation requirements, insulation, window property, what your HVAC system, and a number of other factors, and comes up with the annual energy consumption of that building. We are defaulting a number of the inputs into the tool using industry data sets, including ASHRAE 90.1, ComNet, ASHRAE Fundamentals, and AIA Healthcare Guide, and 62.1. When there wasn't an industry standard default, we data mined the projects that have participated in the Xcel Energy EDA and other utility energy efficiency programs to come up with a good standard. So for example, building geometry, there's not a default building geometry defined. What we did is we looked at all of the schools that participated and came up with a power regression curve of how much envelope area there is per floor area for a typical school, and we provide a geometry that matches that. So you can do your initial SB2030 run even before you've designed the geometry of the building, and it'll give you a pretty good number as long as you have a typical geometry for that building type and size. All of this is done with HTML5 and AngularJS over the web, so you can access this with a tablet. You can access it with a phone, but it gets a little small unless your eyes are really good, or a laptop. You can get to it. All of the modeling happens in the cloud. You don't have to load anything onto your computer other than a web browser. So now I'm going to dive into how you access the tool and how you navigate through the tool. To access the full version of the SB2030 as designed tool, you need to have a project enrolled in the B3 Guidelines Tracking Tool. Within the B3 Guidelines Tracking Tool, you will see the projects that you are associated with, and you can navigate to it. You can see a partial version to set your goals if you don't have a project enrolled in B3 Guidelines yet at www.b3mn.org 2030 Energy Standard. So that'll allow you to, as you're going through schematic design, set what your energy and carbon target is, and then going forward, once you're in the B3 Guidelines tool, you can start to document what your design currently is and how much energy and emissions that would be associated with that design. So within the Guidelines tool, under E1A, you can navigate, and there are 3 separate instances depending on where you are in design. We create a copy of your model so that as you're working in preliminary design, or final design, it doesn't override the previous versions. So you can see how your design has changed and how you're doing compared to your goal. Now I'm going to dive into the user interface of the SB2030 tool. So there are 2 modes to the tool. The first mode is the standard tool, and this has been out there for a couple of years. And then the As Designed tool came out a little over a year ago. The difference between the two is whether you're just setting what your target is, or you're actually documenting what your design is within the tool and seeing how you compare to that target. To access the As Designed tool mode, there's a checkbox underneath the right, at the bottom column, that says Create As Designed Model. If you check on that, you have access to the As Designed portion of the tool. On the top menu of the tool, you will see 5 tabs. There's the Intro, which we just saw a moment ago, a Building tab, HVAC, a Design, where you specify what your energy efficiency measures are, and then a Results tab. There's also a button for a menu where you can enable detailed inputs. The detailed inputs will allow you to set a project-specific schedule other than the default schedule, geometry, construction type, or plug-and process loads. Throughout the tool, we use red to indicate that there is an error, and light gray to indicate that that section is not yet complete. Green indicates that it is complete, and bold is where you are. So here I'm in the HVAC tab. It's red, I have not yet completed it. These gray tabs I have not yet gotten to. So that's kind of the basic schema of the navigation. The red error messages on any given tab, if you've not completed all of the information you need to do to move to the next level yet, you will see these error messages in the upper right-hand corner of that screen. If you hover over it, it will expand and tell you what's missing, what isn't working, what you need to do to move forward. The tool is designed that if you get rid of all of those warnings, you will have a functioning energy model. So it'll guide you to a working model without crashing. Yeah, the laugh is from somebody who probably has done energy modeling before. That's not always the case. When you have a red warning, it also does a red outline of the section that needs attention. So here I have 2 warnings. I have a red outline, and it says no areas are currently assigned to that system. So I have to go in and assign areas for that HVAC system to move forward. Throughout the tool, there are underlined terms. Those underlined terms are definitions or help. So for instance, building type, if you hover your cursor over that, it will expand and it will define what we mean by building type and give you a little bit more information. Space asset area, a number of the different areas you can get more information by hovering over it. Okay, now we're going to go into how you actually build an energy model in this tool. When you first open the tool and you go to the Building tab, it is going to show you the building type that was defined for your B3 guidelines. You can modify that if you need to, or you can edit the parameters of that building type. That building type will set a number of the following parameters that we'll talk about, including the mix of uses within that building. So if you, for instance, pick a school building type, that means you're going to have classrooms, offices, auditorium, dining, gymnasium. You may be a school expansion that is just auditorium, and you might want to delete some of those uses, or you may be a school expansion that is a central office expansion, and it's just office, and you want to have that. So you have that flexibility within the tool. We currently have 45 building types that cover a pretty wide range of the different buildings we see. Again, about 5% of the time we might run into a building type that's not covered by the tool, but it's pretty extensive. If you do have a building type that's not covered, you can select Other and then kind of build it up from the components. We do suggest you use Other rather than just picking an arbitrary different building type. It makes, when we go back and look at things, a lot simpler. If buildings that aren't an office, for instance, pick Other instead of pick Office and then got contorted enough to be whatever they were. So if you have a unique building, you can mix what we call space asset areas. Space asset areas are the building blocks to create these unique buildings. They represent different programmatic functions within a building, and you can combine them. My software folks tell me any number. I haven't gotten past 20. You can do 20 or 30. In general, if you're going past like 3 or 5, unless you have a very programmatically diverse building, you're doing too many, and we'll talk about how you choose kind of what categorization here in a moment. These aren't space types. It's important to consider. They're a wider category than space type. What we found when we were building these tools was that if we just did building type, we ran into problems when you had like a school expansion, or you have an office building that has a dining space and a cafeteria versus an office space that doesn't. But if you go all the way down to space type, often that information isn't really finalized until later in the design, whether it's private office or open office. And you can spend a lot of time getting all of that detailed information in, and it only makes about a 1% difference in the total energy consumption. So we came up with this space asset area to kind of straddle in the middle between space type and building type so that we can more quickly get an energy consumption for a building. These definitions are based on ASHRAE building-wide values and ComNet, and then there are some that emerged as we were doing projects. We found that we couldn't serve certain space types, and so we had to create additional space asset areas. The other interesting thing about the space asset area concept is you can have more than one instance of the same type. So if, for instance, you have part of an apartment building that is served by PTAC and another part that is served by heat pump, you can have 2 different apartment space asset areas and give them different HVAC systems. It also works well if you have an existing portion of the building and a new, and they're going to have different envelope properties or other characteristics like that. You can split them apart and give them different attributes. So as I mentioned, they were developed primarily by using building types to set building-wide characteristics. So for instance, there's an office space asset type. That space asset type includes the functions that serve a typical office: open office, private office, corridors, restrooms, some small conference rooms, all of those things you typically see in an office. Most of them are applied very, very broadly, but there are some that get very specific. Patient rooms, operatory, emergency rooms. Some of the other ones that are set by the AIA healthcare ventilation requirements have their own. So there's a list of them, and you can pick the thing that matches the most closely. There are also some space asset types that are set based on the internal loads being substantially different than others. So an apartment building, for instance, the apartments have kitchens and such, and so that's a very different load than non-apartment spaces. Laboratories, computer centers, commercial kitchens, and others. In general, it's not an exact science. You want to get a good representation of your building. We find that as long as you're pretty close, you're going to be within 1 to 3% of the energy consumption as if you zone it out space by space. So you lose a little bit of precision, accuracy, I suppose, but it takes much less time and you can get results earlier and it's more consistent across multiple users. So a couple of examples to show you how we think about this. The apartments, if you have an apartment building, we don't have the entire floor be the apartment space asset area. We break it out between the apartments on the perimeter and the common area in the center. Similarly, for a patient tower at a hospital, we don't treat the whole floor as patient room because the interior spaces aren't getting the same amount of ventilation and plug loads. We would treat that as patient rooms around the exterior and common areas in the interior. So currently we have also about 45 space asset types ranging from apartment to worship areas. So you have a lot of options to pick from and a lot of flexibility to build up the energy model from. To select the space asset areas, once you have picked your building type, it will pre-populate with the most common mix of space asset areas for that building type. You can add additional areas by hitting the Add Area button. You can delete areas by clicking the trash can. You can also scale them to fit. So if, for instance, you had a 100,000 square foot building and you've added in a couple of new space asset areas, and now you have 110,000 square feet, you can either scale all of them to fit, or you can dial in each one individually and then scale the remaining one to fit the square footage. And as I mentioned earlier, you can also have more than one space asset, more than one instance of the same space asset type. So here we have an east apartment wing that is 2 floors and a west apartment wing that is 3 floors. Once you have set up the different mix of uses within your building, you can dive in and give some other characteristics for them. So if I hit edit on any of these space asset types, we get to this screen. In this screen, we can rename it up above. We can pick the space asset type from the category, set the area and type it in, and the number of floors. Some of them have a unique requirement like number of units. So to do an apartment building, we need to know how many apartment kitchens, how many apartment laundries, all of that. And then this concept we call arrangement. So again, we aren't looking for the exact geometry of a building. We're trying to get 95% of the accuracy with 20% of the effort. So we have this arrangement concept so that we get roughly the right amount of wall and roof area and where it all is configured. The 3 arrangement options are adjacent and at grade, stacked, or hosted. So an adjacent at grade would be 2 portions of a building that really aren't that related to each other. They're basically freestanding versions of those buildings. A hosted would be, for instance, this building has some retail, it has a coffee shop. Those are within the greater shell of this convention center. That'd be a hosted arrangement. Similar if you have a fitness center in an office building, that's going to likely be a hosted arrangement. And then finally, the stacked is literally stacked on top of another one, and it'll ask you which one is it stacked on top of. That allows us to know how much roof area and a good approximation of how much wall area is within the building. You can also do a detailed edit on modifying the space asset area details if you've enabled that detailed mode. So to do that, there's a button called Modify Details. It will allow you to set additional parameters. You don't need to do this to create a model and to create a reasonably accurate model. But if you do have a building that has a particularly high plug load, for instance, it has dehumidification needs, it has something else that is pretty unique for that type of building, you can do this detailed edit. The details you can edit include the schedule, the ventilation rate, geometry, floor-to-floor heights, space temperatures, and plug and process loads. And you can edit those distinctly for each individual space asset instance. So for the operations, you can pick whether the space is occupied or unoccupied and the people density. You can also set a schedule by week and which months those typical weeks apply to. So if a building is occupied 5 or 6 days a week, you can set that. You can say it's partially occupied on Sundays or how many hours per day it is occupied. You can add a second schedule with the button up there. That would be like a summer schedule or something else where it's less heavily occupied or more heavily occupied. The default for all of these schedules come from the ASHRAE 90.1 User's Manual. And then if you tell us you have more or less hours than is typical, we just expand or contract that. So the schedule has a ramp in and a ramp out period. It's not just you're fully occupied for a full 9 hours, but if you tell us you're 9 hours or 12 hours, we'll expand that ramp in and ramp out period. And that propagates out to the lighting, the plug loads, and the people. Under mechanical, you can adjust the set points for heating and cooling, occupied and unoccupied. Those do go to both your baseline and your design. You don't get to claim energy savings credit for different set points. So just something to be aware of. You can also override the ASHRAE 62.1 ventilation requirements if you have specific ventilation requirements, either by outside air per people and area, or you can set air change requirements. If you have a laboratory space, for instance, you can say, I need to have 8 air changes per hour for this space when occupied and 4 when unoccupied. We're going to cover detailed geometry here in a moment, but under the envelope, the basic options are the floor-to-floor height. We default that by space asset type. So a gymnasium, for instance, has a 20-foot default floor-to-floor height. An office has a 10-foot. If you have a particularly tall office space, you can override that, or if you have a particularly short gymnasium, of course. We also allow you to specify whether or not this space asset type is within the infiltration envelope. So if you're going to do reduced infiltration and a blower door test later on, you can decide whether or not this is included in that envelope or if it's a separate portion of the building. So for the geometry, our default geometry is to use what we call a square L. It allows us to have an orientation neutral default geometry with the approximate amount of wall area for that floor plate area for that type of building. If you want to override that, if you say have a school that has an atypical school shape, it doesn't have the typical classroom wings, you can, by each space asset type, pick a geometry. Once you do that, you can segment walls, you can push and pull things, you can pick from a number of different default shapes and change their orientation. These changes have the most impact if you have a mechanical system such as VRF or a heat pump, where you're trying to pull energy from one space and provide it to another space. If you have a central system, it doesn't have that much of an impact overall. Window area, which is shown separately, has much more of an impact. Other architectural features have much more of an impact than the geometry. It's intended to be very high level. You don't need to get every single cutout every time there's a indent for a door or anything like that. The standard shapes that you can choose from are rectangle, L, U, H, T, and triangle. You can rotate it. You can use the scissors to segment a wall and then push and pull to get different shapes. You can also set walls as adiabatic, although our architecture friends told us nobody knows what that word means, so we changed it to shared wall. Adiabatic's an engineering term that there's no heat change through this wall. So if you're building like a traditional downtown where it's just a series of buildings, one right next to each other, and the walls are shared walls, you could have the outside walls, the side walls of your building be adiabatic. Or if you have multiple space asset types that are touching each other, they can be adiabatic. And it can either be the entire wall, or it can be a certain width and height of the wall that's adiabatic. Again, this is trying to get close to the right amount of wall area, although you don't have to get it to be dead on accurate. And then you can also, once you've specified a detailed geometry, you can set your window to wall area ratio by orientation. So if you do have a lot more glass on one side of your building than another, you can reflect that in the design here. So after you've defined the building geometry, we move on to HVAC systems. Similar to the geometry, we're doing the HVAC systems at kind of a high level, understanding the system types. We're not defining each individual HVAC system itself. So if you have rooftop units, and there's 10 of them, don't define 10 HVAC systems. Define a rooftop unit system type. We will propagate it out for a typical distribution of HVAC systems. The first thing you do when you get to the HVAC details is tell us if you have a central plant. So service hot water, what your central service hot water is, if you have central heating, if you have central cooling, and water to air heat pump types. Again, with red triangles will show up if you don't have everything you need to move on defined in the HVAC system. The HVAC systems can serve one or multiple space asset areas, but you can't have more than one HVAC system serving a single space asset area. So as we talked about earlier, if you have east apartments and west apartments with different HVAC system types, when you're defining the building, you need to define those separately. The central plant options for service hot water, you can pick whether it's electric or natural gas service hot water. If you're doing a heat pump service hot water, that's an efficiency measure, and you'll define that in your building design in a next tab over. You can select on the heating plant type, boiler, district, or none, if you have like a furnace or some other system level heating. For the cooling plant type, you can do district cooling, air-cooled chiller, water-cooled chiller, or again, none if you have DX or you don't have cooling in your building. There's also a dedicated outside air system that you can apply. So if you say your building does include a dedicated outside air system, we then will ask what the heating and cooling for that dedicated outside air system, and a range of options there as well. If you do put it on a heat pump, it's going to be the same loop as the other heat pump systems on your building. If it's DX or it's furnace, it's going to be a freestanding unit. After you've defined the central HVAC system, we ask you to define individual system types. So for each system type, you can, again, like the space asset areas, rename them, whatever nomenclature makes the most sense for your project. And then you can you have to assign at least one space asset area. You can't have an HVAC system that's not doing anything for you. But you can also have the whole building on one space asset, or one HVAC system if you would like. Next, we are looking for the conditioning type. Your options are, is it heated only, cooled only, ventilated only, or is it heated and cooled and ventilated? And then system type ranges from VRF, VAV, heat pumps, and a number of other systems. The system types dynamically change what your options are for your system level heating, your cooling source, and your zone level heating. So if you have packaged thermal air conditioners, for instance, there's no zone level heating, it's just the system level heating. If you up above chose that you had a dedicated outside air system, it will ask whether or not this system is served by that dedicated outside air system. And then you repeat this for however many different types of HVAC systems you have throughout your building. The next step is to add different energy efficiency measures to your building. We divide up the efficiency measures in mechanical, architectural, lighting, electrical, plug and process loads, refrigeration, and service hot water, and they get applied at 3 different levels: the facility level, the system level, and the space asset area. When we release the update to the tool in January, we will be including photovoltaic. So if you have solar PV systems that you want to look at, that'll be available in the tool in January. For the mechanical system, at the facility level, you can specify the equipment efficiency. So if you have a central boiler, how efficient is that boiler? Pump controls, power reductions, and dedicated outside air strategies. At the system level, we ask for equipment efficiency for the system level equipment, motor efficiency, fan power reduction, fan controls and heat recovery. And then at the space asset area level, we ask for what your ventilation controls and any thermostat setback controls. So if it's an unoccupied thermostat setback, you can specify that there. For architectural strategies, at the facility level, we set infiltration, and then everything else is set at the space asset area level. Lighting, again, there's facility level for exterior lighting power density reduction, and then at the space asset area, you set your lighting power density, your occupancy and vacancy controls, and your daylighting controls. Plug and process loads, snow melt and elevator are both at the facility level, and plug load and Energy Star appliances for residential and commercial are at the space asset area level. For service hot water, you have system efficiency, whether it is an on-demand system, so a tankless system, and if you have a heat pump water heater is at the facility level. And for the space asset area level, it's residential low-flow shower heads is the strategy we have. And then refrigeration is all at the space asset area level. When you first go into the design tab of the tool, it's going to default you to the current state energy code level of measures, which is more stringent than the baseline model in 2030, because the 2030 model is based on a typical building in 2005, and then you have to get to a reduction. So you're going to end up, when you first come in, with a KBTU that's probably not quite compliant with SB 2030, but also not all the way to the end of what the baseline model is. You can start to add strategies up here and apply them to the different areas, and as you do that, it will update and rerun the model, rerun the DO2 model, and tell you where you are from a KBTU standpoint, and then in the January release, it will also have a carbon emissions factor shown there, so you can see how well your design is doing and whether or not you're going to be compliant with SB 2030. So I'm going to come back to touch on what the updates we're looking at for 2020 are. As I mentioned earlier, we're going to be emphasizing carbon more heavily than we do now. We're going to be adding renewable energy within the tool, as well as having updated criteria for having renewable energy be on the building first, on the site, and then only renewable energy credits if those aren't cost effective or you don't have available space. We are going to update the cost effectiveness criteria. It's looking like it'll be 12 years. The reason that's getting updated is that 30% reduction in carbon emissions per kilowatt hour is actually reducing the benefit of saving energy, which is kind of neat as an efficiency guy. You know, historically, every kilowatt hour you saved translated to natural gas or coal savings. And so every incremental kilowatt hour you saved had a direct savings of fuel and emissions associated with that fuel. As we become more renewable on our grid, the benefits are actually being reduced for every kilowatt hour saved. It's kind of a fun thing to be competing with, you know, renewable energy versus energy efficiency. Like, I'm okay if either side wins on that fight. So we're going to be reducing it to 12 years to reflect the reduced societal benefits to energy efficiency because of those renewable energy on the grid. Eliminating the relaxed standard for renovation, and as I mentioned, adding PV to the tool. There's a couple of resources as you're using it for support. First off, we're recording this presentation and we'll be making this available on the SB 2030 website, so if you wanted to come back and refresh. There are also short videos, about 60 to 90 second long videos, talking about individual components of the tool on how NEO works at netenergyoptimizer.com. The SB 2030 tool is a version of Net Energy Optimizer, so they're the same underlying tool, and those videos would help you navigate it. And then lastly, throughout the tool, under the menu, there is a support button that you can use to email Wildan if you have any questions. It is awfully helpful if you give us a clue of what went wrong. If you're emailing us because something went wrong, a screenshot, a brief description. If you just said it crashed or it did something, it's a little harder to track down and to help you out. So if you help us a little bit, we can be more helpful to you. Lastly, I want to acknowledge our client, the Minnesota Department of Commerce and the Department of Administration, as well as our partners, CSBR, LHB, and CEE. Are there any questions about SB 2030 or the tool? Yes. Yep, so there are some restrictions. The tool is available for, the full use of the tool is available for any building enrolled in B3 guidelines. If you are not enrolled in B3 guidelines, you can use the goal setting aspect of the tool, but it is restricted to just Minnesota. If you're interested in using it outside of that application, I'd be happy to chat with you afterwards. It is available in other applications, but the free use of the tool are restricted to those two applications. Yeah, great question. We update your goal is the short answer. So one of the purposes of having this tool, as opposed to having people doing an eQuest or an IESVE model, is 3 years from now, if the use changes, the state has the ability to update that model. It's not just on somebody's hard drive who might be 2 companies away from there. So we can update that model, update the plug loads, and readjust the goal. We've seen this happen. There was a shelter for formerly homeless people, and they had a kitchen, and the kitchen was designed and expected to feed the folks in the shelter, but it ended up that they were feeding other people as well, and they were providing food to friends and people, other homeless folks. And we don't want to restrict that type of use. I mean, that's a net positive. So what we did is we adjusted the kitchen loads to reflect that, and then the standard went up. There are situations where somebody isn't going to hit the standard, that they're, it's not as efficient as it was expected to be, and then we go through the energy efficient operations module and try to get it as efficient as we can be for the physical assets installed in the building. So far, I think about 10% of buildings aren't meeting their design standard, but 90% are meeting the design standard that they were designed to meet. Yeah, so when the new code comes into effect, we will implement that so that your starting point will be that new code of the kBTU. The code doesn't directly set a kBTU. We model the attributes of the code as your starting point, and then your efficiency measures go beyond that unless you purposely tell us you're doing something less efficient than the code. So we will be updating that when the new code goes into effect in the spring. It is. We have not been putting asterisks on it yet. That's something we've talked about. It shows up the most common in multifamily housing because the Magic Pack units are just so cheap that, I mean, they're so low cost to install that it's really hard to go to any other mechanical system, and so that's where we see that exception showing up the most. So far, the way the rules are being interpreted is, as long as you've shown that you're using less energy than a building that implemented all of the measures that have less than a 15-year payback, you are still SB 2030 compliant. So I'm going to repeat the question. Do we have any challenge getting the outcome portion, the metered energy consumption in the multifamily? Yes. Yes, we do. Most of the places where multifamily is getting pulled into SB 2030 is cities adopting it as a criteria rather than, most multifamily is not receiving general obligation bond funding from the state of Minnesota. So when cities adopt it, they're often adopting not the outcomes-based portion, but that you have to design it to meet that criteria. And that is something that doesn't strictly meet the SB 2030, and so you could say it's designed to meet SB 2030, but it's not the full 2030 compliance if it's just a design and not an outcomes-based compliance. We've been trying to figure out how to address that more fully so that there's some clarity in that, and that we're not watering down the outcomes portion of it so that other entities can also get what they would like out of it. So the B3, so SB 2030, kind of, ventilation and such, it's the energy portion. The B3 guidelines have quite a bit of rules around the interior environment, natural daylight, other things. And then the post-occupancy evaluation is actually going in and surveying office or classrooms and finding out how well do you like this space? Does this space meet your needs? And having a feedback loop so that we're trying to get buildings that meet the needs of the occupants better and better over time. So it's a little bit in the energy portion. It's more heavily in the B3 guidelines and the post-occupancy evaluation. Okay. It is a Minnesota-wide number currently, and we would like it to be more granular. We have an incomplete data set. So the Energy Information Administration publishes the energy used within the MRO West region. So if you look at just the emissions of the state of Minnesota, when they publish it by the state, that's energy produced in the state of Minnesota, which does not count several large power plants that are just over the state border, but all of that energy comes into Minnesota. Some of the larger utilities have data available for them. The problem is if we let them use that lower number and then we keep using the average number, we have to somehow adjust for the average number going up for any time that we let somebody go down. Otherwise, you can't say everybody gets to be measured at average except for the people who have better information, and then we're going to count them as better than average, because then you're unreasonably reflecting a better than average, and we haven't gotten the data for that. So we are hoping to get utility-specific data for the entire state, but we don't have that yet for carbon emissions. So that and hourly are the two things we'd really like to have, because the standard is written in the legislation that it should account for the carbon emissions reductions that the utilities are doing, and the best way to do that would be by utility, but we don't have enough data coverage to do that yet. Yes, so we do have architectural strategies, and so we have insulation, roof reflectivity, glazing characteristics, as well as infiltration. And I should mention, I don't think I mentioned anywhere else, this is a full DO2 model, and you can download it and look at exactly what's in it. So it's right in the tool. You can download the DO2 model, and if you wanted to go crazy, you can make edits to it and rerun it and do other things. When we need to model something that isn't quite covered by the tool, we'll often build the model and download it and then do a hand edit and rerun it. So yes, it does account for envelope and installation strategies. We are trying to capture the question was about, and I'm sorry I'm not repeating all of them, I should. What do you do about the fact that the people who are actually operating it and causing the energy consumption are not the people who designed it, and there can be a disconnect there? We are having people design and showing us an energy model that it can perform to that. And then we're doing kind of 3 checks. Did you design a physical asset that should be able to perform to this energy standard? And then once the building is being operated, we're looking at, are you performing to that standard? Thus far, we've not had to spend a whole lot of time adjudicating if it doesn't happen, why. But basically, to do that, in principle, we would do a energy modeling calibration, where we'd start to figure out why is the difference, and is it because the building is used more heavily? so the Wildan does a lot of energy modeling as part of utility programs as well. And we've seen, for instance, schools always use more energy than we thought they would until we realized new schools are new and shiny, and all the after-school activities happen in the new school rather than the old school. And the school district told us the hours of operation for the old school and the after-school activity density of the old school, we have to kind of correct for that. So because the tool is more automated than most energy modeling, we have a kind of feedback loop built into it. And then when there are outliers who are underperforming what the design expectation is, we try to dig in and understand why and see if it's an operational thing. That's great, because then we can fix it. Or is it something got value engineered out? That's kind of the worst case scenario, because then you just don't have the thing to get to the original energy performance goal. And yeah, we don't really have teeth yet. I mean, the law says the bond funding can be removed if they don't meet that criteria. We've not yet done that, but that's, it would be a mess. We've not gone down that road thus far. The couple of buildings that have not been performing, we've been able to work with and at least get them closer to the original goal. So is it CSBR that's reaching out to the owners, and are we getting back in touch with the architects and doing a feedback loop? It is CSBR. We are usually reaching out to the architects as well, because we're trying to understand what happened, and so we're having discussions with the architects and engineers and contractors and owner to try to figure out what's happened. I don't know that we're doing that perfectly on every time, but when we've been doing that digging in, yes, we get the design community involved in that discussion. So the question was about the fact that we're removing the relaxed standard for renovations. So there's two things there. If it would create an unhealthy environment, we would accept you out. I mean, if you were going to create a dew point type situation, that's not healthy, even if it saves energy. That's not the intent of the program. The second thing is that usually in that type of situation, adding the insulation wouldn't have a 15-year or now a 12-year payback anyway. And so that is, we would expect renovation projects to pull that lever more often. That, the original scope of the renovation was lighting and HVAC, but to get to 80%, we also had to do, an envelope upgrade, and that had a 30-year payback, so that's why we're not doing it. And then thirdly, what we have seen in both the utility work we do and in the SB2030 work, as long as you're touching two of the three major systems, lighting, envelope, and HVAC, in general, we don't see a significant difference in the performance of new or existing buildings. Historic buildings, probably an exception, but if it's just a standard renovation, the average renovation, they can get to the same typical outcomes usually. The envelope, again, historic, totally uninsulated would probably be an outlier on that, but as long as there's some insulation with HVAC and lighting, you can often get close to the same point. So. We typically see no benefit to a minor penalty for white roofs in Minnesota. No benefit at the building energy consumption. Let me phrase it that way. That we have enough roof insulation for a new building, and buildings are heating load dominated up here. It's somewhere between here and Des Moines where we start to see a marginal benefit for having a white roof from an energy standpoint. Frankly, we have white roof here because if we don't, we get asked about it over and over and over. So it has a very low impact on the energy consumption of a building. But if we don't have it there, we kept getting asked about it, so we included it. The air temperature above a roof, there's wind, in particular if you're up a floor or two, it's not gonna, there's all sorts of discussions about, how much of a heat gradient is going to be maintained right there. For these climates, it's not a big benefit. What it does help, and why it's a separate point for LEED and for other green building rating systems, is a heat island effect for the neighborhood. So for your individual building, you might actually consume a little more energy. But when we have acres of asphalt and dark roofs, the whole city starts to heat up a little bit. And if we can reflect that back, that has a heat island impact that is perhaps greater than the individual building impact. Thank you so much for attending, and my email is here. If you have any questions, it's cbaker@wildan.com. I'm almost used to saying Wildan instead of the White Group. It's taken a few months, so thank you.